Okay, so on your homework, both of you, on your idea math homework, both of you had a question about counting paths on a cube. Alright.
So you could approach this in the same grid counting way that we did with just a normal grid.
Alright.
This is one.
So we do have to talk about what the restriction is here. So we can't go backwards.
Said on my problem, you have to find the shortest route possible, and
Okay.
then find how many of those are there. So on this, you have to cross 3 edges.
Yeah. So you could say on this one you always have to go up to the right, or sort of.
Up to the
Back.
right and to the
Well,
back.
in 3 dimensions, up in 3 dimensions. So basically you have to walk a positive direction in the x, y, and z.
Yeah.
We could say.
There's one way to get to each of these 3 points. And then the next set of 3. This one there's 2 ways. This one there's 2 ways. And this one there's 2 ways.
Okay.
And for a total of 6 ways.
Okay. So we could use the same grid counting mechanism in 3 dimensions.
Yeah.
Is there a way to understand that 6 in terms of choosing numbers?
Well, you have to choose. You've got 3 spots, and you have to choose 1 to move in the x direction, 1 to move in the y direction, and then the z direction is filled in.
Okay.
This is 3, choose 1, times 2, choose 1, which is 6.
Okay. Can you think of any explanation in terms of choosing numbers? Or not even necessarily in terms of choosing numbers. Can you see any other way to see why this has to be 6?
Well, you have to pick the order in which you go in the directions.
Okay. So what do you mean there?
So
Let's call the directions x, y, and z.
So-
Just to avoid saying up.
So you have X, Y, and Z. You can move X, Y, and Z in the first one. That's 3 choices. And you've used 1 already. It's 2. And the last one is forced. So 3 times 2, 6.
Very good. Okay, so now I'm going to give you guys a challenge, and we're going to count the total number of directions to go from corner to corner, not on a 1 by 1 by 1, but on a 2 by 2 by 2.
Alright.